Hello, and welcome to this panel discussion about creating and analyzing big data as part of our Defining the Smart Manufacturing Journey series sponsored by Rockwell Automation. My name is Matthew, and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today. Just to the right in the main presentation window is the speaker bio window, with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce our moderator for the Defining the Smart Manufacturing Journey series. Let's welcome Edgar Sauter. Edgar is the Senior Director of New Product Technology at CSA Group. He and his team look to the technology horizon for new developments and applications that could present opportunities for CSA's test, inspection, and certification business. To read more about Edgar or any of our presenters today, please look at the speaker bio window right next to the main presentation window. And with that, I would like to pass things along to Edgar to lead us through today's discussion on creating and analyzing big data. Edgar, welcome to today's event.
Thank you, Matt, for the introduction. I am Edgar Sauter, Senior Director of New Product Technology for CSA Group, and I will be moderating this panel discussion today. We are very happy to bring you this exciting discussion about how engineers are collecting machine performance and health data and turn it into actionable information. This is the essence of big data. So today with us, we have a set of experts in relevant areas to this topic to discuss how big data is transforming traditional manufacturing. So with us today, we have Mohsen Sefer. He is manager for new product technology at CSA Group, where he develops testing, inspection, and certification programs. Mohsen holds a PhD in electrical and computer engineering, as well as an MBA. He has 15 years of hands-on experience in advanced technologies in a variety of manufacturing disciplines. We also have with us Ryan Kershaw. He is an enterprise account executive with Litmus, an accomplished Industry 4.0 networking vendor. He is also a board member of the Smart Manufacturing and IIoT division of ISA, where he works with the Industry Readiness and Maturity Committee. We also have with us Dean Phillips. He brings 34 years of smart manufacturing experience. He's an advisor to SME's Smart Manufacturing Advisory Committee, and he's an accomplished speaker in IoT, AI, robotics, and AR and VR. He's also an entrepreneur and has served on the board of directors or as an advisor for multiple technical committees. We also have with us Tim Shimbara. He is the Chief Technology Officer for AMT, the Association for Manufacturing Technology, where he is responsible for industrial research and development, standards, and technology discovery. He has ample experience in the US manufacturing technology, including policy development. And we also have Jared Comer. He is an information and analytics technical consultant for Rockwell Automation. He has 20 years of architect, analyst, and consulting experience in Canada's automation sector for petroleum, process, manufacturing, and enterprise market. So Dean, Mohsen, Tim, Ryan, and Jared, thank you very much for being with us today, sharing your knowledge and experience with our audience. So in a manufacturing environment, there are tens of machines, hundreds of machines, and probably even hundreds and even thousands of sensors. So many that they can overwhelm any engineer with data and information. So how can an engineer make sense of all this data? how, how to extract the actual valuable information for it. So these are some of the questions that we will discuss today with this group. But before we start, let's have some acknowledgement to our sponsors for today. So Rockwell Automation is a global leader in industrial automation and digital transformation solutions. Rockwell's inherent expertise in industrial networks, sensing technologies, and digital software means it is one of the preeminent authorities for everything in smart manufacturing. For more information, visit rockwellautomation.com. This webinar is hosted by Global Spec, the world's largest online destination for industrial product sourcing and engineering information. So without further delay, let's start with our panel today. So I would like to start, for the benefit of people who are new to this topic, with a very simple question. What is big data? And how is it different from the previous ways to kind of monitor performance of equipment? Like, I mean, electrical utilities and other industries had SCADA for years. So what is the difference? What was before with big data?
Yeah, so I'll take that first one. I mean, it's interesting where we see, the industry 3 to the industry 4 shift, when we go from, like you said, the old SCADA systems to the newer sort of IoT applications. I mean, the jump from, the older way of doing things where, we'd collect data and we'd monitor data, we'd analyze data. We now move into the applications where we can then start to take in data from all sources. We can start to apply more advanced analytics on top of it. So data we might not have seen as being important beforehand, maybe serial numbers, temperature variations within certain applications. We can put that out to a machine learning algorithm and maybe even turn that into something we can use for predictive analytics, for looking at quality applications, anything like that. So I mean, that's one of the big steps. And being able to do that then requires us to start taking data from absolutely everywhere. I mean, we look at old sensors where, we'd have a 420 coming out. Maybe if we were lucky, a heart signal on top of that. So you'd have your primary, secondary, tertiary, and quarter values. I mean, 4 values coming out of the sensor. We look at new ones now where we're getting 10, 20, 30 values coming out of something like that. It could be something as simple as a serial number, maybe even an on-off type response. But all of this can then be used for these more advanced applications. And I think that's really the big step between what we used to see in terms of data coming in from like a SCADA system to something more along the lines of IoT, where we're now looking at trying to take that data, not just make a product, but make a product much better, and use that data to really inform upon that process.
Well, touching on the lines of IIoT, especially, people always ask, what does that even represent? Industrial Internet of Things. It seems like a moniker that doesn't explain a lot. And I always describe it as, break it down to the acronym IoT. It's that convergence of the information technology space and the operational technology space that have been diametrically opposed for years in manufacturing. Basically, what we're trying to do is blur those lines and extend that information up to a higher place. And so when I hear big data, the biggest thing is we're not just conglomerating information now from certain areas. We're not having islands of automation where small amounts of information are being viewed. We're now looking at entire plants worth of information being brought into one space, entire enterprises being brought into one space and being able to be evaluated against each other. What's working in Chicago might not necessarily work in Akron, Ohio. And looking at that from a space of, hey, I can have a larger sample size to really understand what's happening in my business, what works and what doesn't. That sort of defines it.
Got it. Now thank you very much, both of you, for the comments. Those are great to kind of ground the topic. So let's zoom a little bit out and see the whole process from the acquisition of the data to the analysis here. So sensors, they play a big role now on acquiring that data, right? And you mentioned that the amount of sensors that are now in place are big, and the information they are gathering is huge. So how can an engineer decide what is an appropriate sensor or not? And what I'm meaning is about quality or the type of things that is gathering. There is many vendors of sensors in the market. So what are those things that an engineer have to keep in mind when is looking into sensors?
Yeah, I mean, it's with any sort of data application, garbage in, garbage out. I think you look at what you're gathering from the field. And there's a couple different things they first have to look at is the quality of sensor. What information do they need? How good, how accurate of a value do they want to get out of there? That's going to have an impact further on down the line. They're also going to want to see how much data they can pull out of a sensor. All of this, they get that good quality data coming out at the base. They're going to end up, seeing the value later on. Again, talking about advanced analytics, there's a lot of values out there that now are going to become important, maybe further down the line as we apply more advanced methods to analyze that. It's something that really has an impact on there in terms of how to determine what data to get out of the process. I think it really has to start from the top and work its way down. We look at manufacturing, and you go back to the old Toyota method of asking why. Ask why 7 times and you'll get down to the root cause. I think when we look at what data we need to look at for these applications, I think the question has to be how. You start with the strategic initiative on there of, let's improve manufacturing and say how. And then you go down to the next one. Well, we're going to measure OEE. Okay, well, how are we going to do that? Well, we're going to have to measure the APQ on there. Okay, well, how are we going to do that? And I think, by asking that question, you'll start to see the data that's required to build back up to that initial strategic initiative on there. Starting with that, really being methodical about how you approach those applications is really going to have an impact, and just to ensure that you don't kind of get lost in all the data that's coming out of a process like that.
Thank you, Ryan. Sorry, Dean, it reminds me what Ryan just said in a comment that you made in a previous meeting of this panel, when you say that Albert Einstein mentioned about that not everything that counts should be count or something like that. So how does apply? How that comment applies to this thought here?
I think to kind of go back to the element of that Ryan was talking about is understanding the process as a whole. I don't think that IoT or IIoT replaces lean thinking or Six Sigma processes. You still have to understand the process before you take that step of how you're going to gather data and interpret data. You talk about OEE. One of the problems that you have with it is so many companies that I go into, they have their own interpretation of what OEE is. At the base, it's, what are you doing 24 hours a day, 7 days a week, 300? Well, they want to then take that and say, well, that's not how we interpret OEE. We weren't planning to run that machine, so therefore we're not factoring that in. You have to have some realistic objectives of what you believe your data to be so that you can accurately represent that and then take it to the next level, which is acting upon it. Because at the end of the day, data that isn't acted upon it is useless.
Correct. So that's a very interesting point. Now, before we jump a little bit more into the data, I want to kind of have some clarity on the deployment of the sensors and what is the proper way to do that. And there are 2 things that concern me. It's like, how do we know that the quality of those sensors is appropriate and that they provide the actual good information? And most, and you probably have some ideas on that based on the standards and certification. That's one question. And the other one is, how do we really manage the amount of information that each of those devices provides? Is there any way to consolidate the data before it completely goes into the network? What are the practices to do that? So if you don't mind, let's start first with the question about the quality and safety, and see if there are ways to guarantee that we are kind of acquiring proper sensors, and then move to the second question of how to manage that information. So Mohsen, if you don't mind to start with that.
Sure, yeah, that's a very important question, as highlighted here: quality, performance, safety. And there are other terms as can dig into the discussion, which is the reliability, and it's going to be the long-term performance as well, which is going to be at the next level. In general, normally all of these terms, quality, performance, is depending on the job that is going to be done based on the sensors, the type of the information, the type of the technology implemented, designing a stage. So it's a two different aspects that should be considered. Manufacturer of the technology, the practices that will be used, all is going to generate some sort of practices, or let's say testing, that we can use for the quality assurance, quality control, which that's the normal practice. Normally, for example, a standard development happening in a way that the companies or the technology developers gather around and provided a unified test method for a specific technology, like a camera sensor, or like, I don't know, like other types of devices. But as we move forward with the long term, then there is going to be the interaction. Depending on the type of the application, what's the danger, or let's say the safety aspect. These are something that can happen as the operation happened, the experience came into the, for example, the failure, the safety incidences as entered into the market or entered into the manufacturing. We can implement some best practices for example, defining some boundaries, defining some specific measures to avoid safety. And the next level after that coming the reliability, how to make sure that, how to compare and make sure that the device, the sensors is reliable in respect of, okay, over the time, the data that's going to be obtained is going to be sustainable. This is something that normally happens at the next stage, because these sensors should be implemented, then we can compare over the time how is the reliability and then define the practices. Currently, for some technologies, there are very well established standard and methods already developed, but for some new type of technologies, new type of sensors like LiDAR, there is an ongoing effort to define a unified methodology in order to be able to achieve these goals. And that's the pattern.
Fantastic. Thank you, Mosen. Now, what about then the collection of the collection of the data from the sensors? Like, how is there a way to avoid jamming the network with data, causing issues? Like, I mean, we may have heard about edge analysis or something like that. So, what hardwares are out there to support this?
I think the question, so I mean, I guess one thing to talk back to the quality of sensors, there's a phrase that always goes in picking instrumentation is, do you want to pay now or do you want to pay later? That's the simple answer, which is, okay, you can put in a cheap sensor that has very little information, that might be analog, that might have low quality, and it'll get you by. But at the end of the day, you're going to be replacing that sensor with something more high quality later on down the road, because your needs will change. So future-proofing your ideas is a great idea. In terms of where that information, or I guess, how do we manage that information? The first question you have to ask yourself is, where does it need to go? Does this information belong at an enterprise level? Is it something that, an enterprise level process engineer needs to see? Or is it just something that the floor needs to be able to see to make reactive decisions? Is it something, the analytics space is changing in the way that we don't necessarily need to conglomerate every little bit of information all the way up to a main hub and do some massive amounts of machine learning at that point. There are edge analytics tools that belong down at the edge, things that need to make microsecond decisions and have microsecond different predictions. That belongs there. That is a closed loop that can stay there. Absolutely. In terms of trying to bog down your network with information, at the end of the day, every company seems to think that they have to revolutionize their data structures and completely do everything all at once. And that's not the case. You take your data strategy piece by piece. Rome wasn't built in a day, is the concept there, which is as you come up with use cases, as you come up with needs for that information, that's what gets shifted up, and that need is met, and it should be constantly reviewed. Hey, are we using this information? Are we not using this information? Can this be archived, or can this be live information? Can this be calculated at the edge, or can it be calculated up in the enterprise? At the end of the day, every bit of information that moves throughout your business needs to have a point to it. It's not just there for fun. Now, that's the beauty of some of the sensors, is they can have that information available and not be taken advantage of. And that is perfectly okay. The reason you pick those sensors is because when you do need that information, you're darn glad it's there. So at the end of the day, it's really coming up with, and this is a specific term, you need a data governance strategy. So if you have a data governance strategy, you understand where that information needs to lie, whether, Joe Schmo up at the top end needs to be able to see that, or, Rick Smith on the bottom needs to be able to see that information. And everywhere in between will determine where your servers sit, where your information sits, whether you need cloud computing. All of those answers come to you once you've determined who needs to see that information.
Understood. Now, Tim, I am curious, because I think this follows in your area. So in this sense, how concepts like information modeling and interoperability falls in here? What is the role of those concepts here now?
Yeah, we primarily so far today have talked about the collection of the data. Maybe there's some filtering of the data. Certainly we see from an MT Connect Institute standpoint, so AMT manages the standards development organization, the MT Connect Institute, and it provides that information model plus a semantic dictionary for this discrete data coming off. The way we see interoperability occurring is there are ways in which the information model will first structure that data and define and put context. That's the semantic part of it. So we actually know what it is that we're getting. And then that needs to get to the people, much like what Jared was speaking about. And you could do that with rules, regulations, that you publish, subscribe type models as far as what devices get what kind of information and when. So information modeling in this case is helping us to best adjust what data needs to go where. You can architect and you can transport over a different transport protocol for that data to go up. And you can also have with the context things that we're seeing a trend in is just anomaly detection. Do an initial thing up front where you benchmark certain things, and then the information model can have this category container for just anomalies. And maybe we can identify and codify that anomaly, and then that goes to QA, or it goes to ME, or it goes to ops management, or it goes up to whatever it might be. But the information model is this key portion that takes all that data, structures it, categorizes it, defines it, and then places, if you will, in the pub sub model of who needs to see what, when, and where. And we're starting to see a lot more scale when the information models are starting to be a part of the architecture.
Let me break down exactly why an information model is extremely important. When I talked about the fact that we're going to start bringing information not just from the factory floor, but up into the enterprise, when you look at a PLC or any of the tags in your historian, you say, hey, I've got a historian, I'm fine. Well, say that pressure transmitter that's sitting in area 4 of a roasting facility. You know what it's called in the PLC? It's called PT or PT202 or PT404. So that executive manager that's trying to look at pressures across an area now has to somehow understand a P&ID drawing of what exact pressures are in that particular area when he's trying to do a pressure analysis across multiple, say, gas turbines. At that point in time, you have to really think about who's looking at the information again. And so the information model is a huge tool and a necessary tool and needs to be part of your data governance strategy in terms of making sure that you can effectively organize that information so it's easier to look at later. Because if stuff's hard to look at, it won't get looked at. And the whole concept of IoT is trying to, I like to call, make it easier to suss out a hunch. Basically, right now, if I sit here and I think, hey, you know what? I think weather might have something to do with what's going on, or I think pressure might have something to do with what's happening over here. If it takes me so much effort to get to that conclusion of yes, it does or no, it doesn't, I'm not going to look. And that's the whole point, is making that information available to people so that they can look easier. And the concept of starting, at the beginning, is somebody's got that crotchety old bum that's sitting on the line that knows that process so well and has been able to point to machines and say, yeah, that's going to fail soon. But the problem is those people are retiring. Like with the pandemic, people left this industry. And with that came so much tribal knowledge of the machines that they have. And unfortunately, that just isn't easily passed down. Anomaly detection is something easy where you can start to have other human beings physically look at the information, not just have to go and flip through pages, and then start instilling that into the hands of a machine or an AI bot that is going to be able to make those predictions for you.
Yeah, it's interesting.
To round this out, real quick, Ryan, to round some of this out, the standardization behind modeling is also when you don't have the same OEM or controls or anything else in it. ON and OFF means, or it might be described a certain way, but even though it means the same thing, and that's a whole nother ballgame. But Ryan.
Yeah, no, I was going to say, actually, Jared brings up a great point, and he points to the PT or what have you name on there. Coming from ISA, we're seeing an interesting little shift in how things are being done. I mean, the ISA 95/Purdue model, I mean, everybody's kind of looking at it saying, asking, how outdated is that? Do we still need to apply that? And I think we can start to get away from the actual application of it, because we are seeing applications where we take data right off the line, put it all the way up to a level 4, or even as some people are starting to call it, cloud and level 5. But the naming convention still applies. It does. You're almost ending up like a scientific name for a mouse or something like that with some Latin string on there. There is common names that definitely help things out. But I mean, I think having a standard in place, a model that you can go to, really does help. It can be a little clunky. Yes, there is a lot of learning that has to be done based off of that. But applying that at least for a naming convention, I still think has a lot of impact on it.
And naming conventions don't happen overnight. Start small. You start with area by area. You work it out, like I said, as you go through business cases. Industries need to start investing in this realm, but they can also do it sensibly and make sure that every single one they're going after is going to bring value back into the business. And I almost guarantee it's going to in some way, shape, or form. And if it doesn't, that's even better. You've discovered something that, hey, that information is not valuable to me right now, and I really can't find value in my business with it. So I'm not going to focus in that area. I'm going to make sure that I'm going to get value out of the areas that I need. You bring up an interesting point too around the ISA 95 levels. The concept in my eyes of Industry 4.0 is breaking that barrier between the IT and the OT layer, that level 3 to level 4 layer, where so many people have thought, okay, it stops at level 3 and then level 3 has to transact up to level 4. That's not the case. We want level 1, level 2s. We want somebody who's sitting in Cleveland who gets an order for 1,000 Snickers bars to be able to very quickly and easily understand, okay, Ohio's got capacity, Texas has got capacity. Oh, over here in Milwaukee, hey, their plant's down. They've got a plant down issue. They're not going to be able to take this order. Before, that was phone calls and emails. That information should be available to absolutely everybody, and it makes business decisions more agile, which ultimately leads to better production.
Now, Jared, I wonder, and sorry to interrupt there, I wonder if following that path, does it make sense to have that standardization across like a whole industry instead of just an organization?
Oh, that's a tough one. Instilling standards on entire industries has historically not done great, mainly because our businesses and our manufacturing sectors are still ran by private corporations that want to run or have their own, special little flower. I mean, I've worked in the SCADA standardization business for almost my entire career, and nobody does it the same. Now, everybody does it the same within their own, or they try to, within their own bubble, but nobody does it the same. And the problem is if you try and standardize and fit everybody into the one melting pot of a standardization array, you can come up with suggestions. Absolutely. And I think S88, in terms of organization, I think S88 does a great job of saying, hey, this is sort of how you should we recommend you sort of organize your information. The biggest and most important thing is that everybody in your group, everybody within that manufacturer is aligned on that organizational tool and that structure. But in trying to instill it across an industry, that is a tall task, especially considering how unique and diverse our industries are getting at this point in time.
Yeah, understood.
Go ahead. I think I think some of the best standards are pretty much just frameworks. To Jared's points, everybody's unique. I mean, there has to be sort of a framework of how you're going to organize things. When it comes down to the nitty gritty of it, I mean, everybody's going to implement it their own way. And it's, as long as you've got that framework to follow, I think it does help. But yeah, you're going to be changing industry by industry for sure.
Got it. Now, I was thinking now about when you were talking about how to visualize data and how to take advantage of that. What if I am an engineer and I realize that an information that I think is valuable for a process is not in my set of data, and probably like I want to put a sensor to measure it, but there is no actual sensor for it. Is there a way to get that information from other data, or I don't know, or magically try to guess what the parameter that I'm trying to measure is?
You've defined a soft sensor, my friend.
Yep.
Basically, at this point in time, we've got a wonderful wonderful ability now in the industrial automation space to measure things that never even were measurable before. Caustic materials, for instance, and looking at level sensors. If you have correlation, you can come up with a prediction. That's the biggest thing. So, for instance, power or voltage and amperage. Well, I know if I know voltage and I know amperage, I can figure out the power. I don't need that physical input. that's a very, dumbed down sort of example. But if you have correlation between certain sets of variables, there are tools out there, and I could say them from Rockwell. They are from Rockwell. There's others from other industries and other suppliers as well. But a soft sensor is that answer. And it's at the end of the day, that is going to be what applies to or allows you to say, hey, I can't quite get there, but I can get there if I have all of the other pieces of information available to me.
Yeah, it's an interesting.
Sorry, Dean, go ahead.
I was just going to say that's an interesting perspective, because one of the problems that I see in most manufacturers is they have a difficulty. They have a system that gathers information on one machine. They have another system on another machine. Problem is on the back office side, gathering that data in, it may be formatting. What do you call it? Maybe I'm gathering things in minutes or versus seconds. Maybe it's coordinating what I have to convert to. Sometimes it's just what things are referred to as, and mapping that from point to point becomes the hardest part. For most companies, that's the problem that they are faced with right now, is getting all of this into their system to say, hey, how do I get this out so I can get it in a usable and a visual format for our people when I'm gathering it from different systems that don't specifically talk to one another. And I think that's one of the challenges, kind of what you're talking about, of gathering that information is very valuable, but getting it into a format, that's another challenge.
Yeah, and that's, I mean, if that can be accomplished, and you're right, that is a huge challenge to overcome. But I mean, the benefits and advantages of being able to do something like that, I mean, to Jared's point, I mean, soft sensors are incredible things. I mean, we look at even, we could take, if we can meld the process with the LIMS system, laboratory information management system. I mean, you can then start to look at, good, bad products before anything has even been, completely finished off there. I mean, going back to soft sensors, I mean, we dealt with this, my last place, look at conductivity, relating it back to chemical concentration. I mean, something like that can be, one of the simple ways to do it. Taking two measurements and, outputting a third based on, a calculation. But yeah, if we can get everything going together, then we can get into the really cool stuff. And that's, taking the laboratory measurements, applying them back through to the process. Process fingerprinting is always another big one. And, again, it's really, really cool stuff if you can make it happen, that's for sure.
At the end of the day, this comes down to one phrase, which is correlation will set you free. At the end, before correlation was in everybody's minds. It was like, hey, I know that this feeds that. I know that this feeds that. If you ever look at I think it was, I can't remember who put it out now. Somebody put out the manufacturing analytics ascendancy model, which was the level 1, level 2, level 3, level 4 diagnostic, descriptive, diagnostic, predictive, and prescriptive. And I always say to a lot of my clients who I've talked to, and an easy way to understand this is to move right or to move along that is to take the decision-making process out of the hands of a human being and put it into the hands of the machine. But the thing is, what you need to think about is I need to have a human being doing it first. So making that information simply available and visualizing it, that's your first step. Organizing that information properly, and you start to realize how wildly important a good data governance and good data aggregation strategy is. There are tools out there that talk to lots of stuff that can conglomerate and organize that information. That's the first step that you need to look for. But once you've started actually visualizing that, you will have smart individuals that understand your process down to a T, start looking at that and going, oh, I'm noticing this, I'm noticing this, I'm noticing this. When I walk into a customer who says, I want OEE, my first question is, hey, could you tell me how often that one machine goes down and why it goes down? If you can't tell me those two simple answers within like a 10-minute span, you need to seriously rethink where your information is and how easy it is to get to. Because if it's hard for you to get to, how can you ever hope for a machine to be able to pull it out?
Right. That's good. So now we have it at the point that the information is here. We have a lot of information. And we have talked on how to avoid to be overwhelmed with data, like how to start looking into what the problem is, and they go from there. So now that we have the information, how can we automate the process of getting actual actionable information from there? Because yes, I can have a whole dashboard telling me all this stuff, but that can be confusing too. And we want to optimize things. So what's the next step from there?
There's several of them. I mean, like I said before, visualizing that information, when you put stuff on a board, I say this to every one of my customers who turn around and go, well, I can put like all of my process parameters on one screen. That's not necessarily valuable to you. You need to start vetting what process parameters are valuable, what process parameters aren't. Start thinking of the questions that you're trying to ask about your organization and about your actual implement or your the things that you're looking at, and figure out, okay, what's going to drive me towards that answer. In terms of the next step, it's having people understand what data is valuable, what data isn't valuable, what correlates, what doesn't correlate. And you can use tools like AI sensors, for instance. You can use machine learning and condition-based monitoring sensors to help you understand where there is correlation, which is exactly what those are for. And once you have that, your next step moves into predictive control, right? So ultimately, your goal is, I want to figure out why something's happening and I want to prevent it from happening. That's the coup de grace, right? So I either want to know when that machine goes down and why, and I want it to tell me, hey, I've got a high risk or a low risk. I want to know when quality is going to come up bad so that I can avoid it by doing this, and this. I want to understand when my production is probably going to run slow across the season so I can sort of plan my schedule accordingly. All of that, when you've named problems. So the first thing you need to do is name that problem and then figure out, grab your team of experts to figure out what feeds that problem and test. And just keep going through that continuous improvement process of coming up with a problem, figuring out what information feeds it, utilizing the tools that are in the manufacturing industry today, and also the experts, the SMEs that you have in those spaces, to try and figure out what information feeds it, utilize the tools, and get to a final, whether it's an edge analyzed or sort of, an edge analyzed predictive model that will automatically detect the moisture content and say, hey, you need to put in, 1.55 millimeters or, percent more humidity in that particular package to get optimal freshness in your food. Or you need to put in 5 cups more dough into your large batch because that's going to be able to affect your dough consistency at the end of the day. Those answers come from working backwards from the problem. I hope that makes sense.
Yeah, no, thank you, Jared. Now, I have a question here because I know that one of those tools, as far as I heard, is, we have machine learning and artificial intelligence. So, Mosen, we talked about this before. So what's the role that they play here in data analysis?
That's a very good question. Specifically, as we see recently, there's a different expression of artificial intelligence, machine learning, and data analytics. And let's define in a way that, what's the differences? Because that's the key part that's going to give us some sort of sense of what will be the application of artificial intelligence and then machine learning and data analysis or data sciences. Data analysis, as the name shows, is the whole process of getting meaning out of the data through processing, through analyzing, visualization, to get a meaningful, for example, finding a pattern inside of a data in order to get a useful application. Artificial intelligence has been in the discussion for so many applications, but as the name shows, that it's some sort of that you are trying to augment the human brain, or let's say intelligence inside of the system. So it's a tool that you are going to use as a way of analyzing and somehow intelligence and operability and reliability in order to analyze it with the data. Machine learning, on the other side, is the substance of the artificial intelligence, which is the tools to provide algorithm with the neural network, different aspect that you can define a tools to give the learning experience in the artificial intelligence without the human. And that's the area that artificial intelligence and machine learning is going to be applicable for the data analytics. It's something that coming with the idea of that without the needs of human, we can operate the data, we can learn from the data, and machine learning is the tools that artificial intelligence will be used.
Got it. Now, Tim, are these tools having trending in the industry, in manufacturing? Are companies really trying to transform their processes to it, using them?
Certainly by name. Yeah, they'd love to. They're shiny, they're new, and they have sweet definitions. But I think a lot of companies are still very confused on exactly what they do in their business. Right. It's growing. What's nice is that the definitions are coming farther and further away from wonderful marketing terms to we've got capable individuals like the folks in this group that are able to break it down and actually explain what each one of these mean to people, rather than just slapping the word AI on one of your machines and saying, hey, it does machine learning.
That's true.
People are starting to be able to actually provide a roadmap for how that gets done. And so you're starting to see it slowly.
That's true. Now I want to hear from Tim, because he has the knowledge from manufacturing technology, the organization. He's really familiar with the trends. So Tim, what's the trend now on that? Are like companies using it?
Yeah, we see two trends happening. One, just to tag on what Jared said, most of the folks in the small and medium business world, they're not going to have the staff, they're not going to have the competency, they're not going to have the time, they don't care. They just want to know that something works, that it happens to be baked in, all the better. They don't care. So there is a trend of that segment being filled by smaller businesses who understand that. The same way none of us on this call necessarily could list the 60-some protocols it takes to order something on Amazon. They just want to know that they can push a button and things happen. So that's one trend. The second trend is we are seeing quite a bit of the machine learning side of the house. You know, if you dive into those things, some of the best parts of ML are the classification, the categorization. So it's that first level that we talked about on this call of correlation. It's, you know, can I just group it and can I link that group? So the trends there are certainly coming into fruition. I mean, when I look at the 7 or 8 most talked about technologies under this broad thing called AI, I mean, usually it's the ML, it's the natural language processing, it's graph, it's all these other types of technologies that we're seeing come into the production facility. But again, don't forget this whole topic of big data. Not only is it just volume and manufacturing, we've known that story for a long time, but now because of these different sensors that are enabling different types, we have types, flavors of all kinds of technology that's disparate. So that's another area in which this ML and the natural language processing, along with some graph theory, are starting to paint a much better picture for us, something that we can do something with to get those correlated dots connected, if you will.
Sounds great. Thank you. Thank you very much, Tim. So now I am curious, just staying here, because we heard from Jared before about the issues about standardizing the way we name the data across industry. But there is also a value on the standards. And Tim, following with you, because you're familiar with that topic, how does the harmonization of standards help to scale digital manufacturing and its data?
Yeah, and we've seen it actually the opposite. We looked at it from an enterprise scalability challenge and what must be in place for that to occur and be successful. It has to be the standards harmonization. There is not one standard to do anything. Almost at each level, if you want to talk about OSI or you know, ISA 95 type models. So two things have occurred that we've realized. One is more standards have to quote unquote harmonize. In other words, work with another standard, which is different, by the way, than a reference spec, which basically says I have blocks 1, 2, 3 connected, you know, provided by my standard. Blocks 4, 5, and 6 are reference to another standard. You go do that to do that part, and then you come back maybe to this standard or other standards. So that's a reference standard. Then you have companion specs, and these are ones that are much more about the mapping and different things are happening. Regardless of what flavor, the harmonization across these standards have to be in place, because there's no way that you would want to, I should say, especially as an integrator, have to either create drivers for each time you want to do a thing or spend a bunch of CS hours trying to connect all this stuff. The standards themselves, we owe the industry as SDOs. We owe the industry abilities for the standards to harmonize more easily, which brings me to my second major point, which is we've even moved MT Connect knowing that, the harmonization challenge, to a model-based standard. So following SysML, you can follow some UMLs and some other flavors, but by having a machine-readable standard, a model-based standard, the ability then for those standards to connect and communicate, even passing data to and fro, becomes a much easier process. And we've also found, because we just did our first version 2.0 as a SysML model, it's actually much easier in terms of time to market and the right inputs to develop that standard. Much easier to have a model-based standard that can be viewed like a folder structure, and you can check for certain things for redundancies. And some of this sounds to people who aren't in the standards world as a no-brainer, but mostly standards are paper-based. It might be PDF or Word document, but it's people who fat finger an I versus a T or a semicolon instead of a colon. And And as you read it prescriptively. So you'll do exactly that. I'll put a semicolon because you put a semicolon. Well, that didn't work on the implementation side because it's supposed to be a colon, right? So a lot of these things, because of the speed to market and the dependency of these standards to harmonize with one another, I mean, it's driven our own institute, MT Connect Institute, to move towards this SysML model. And we talked to the ISO folks. They're starting to do similar things. And we're not the only ones, but there's only a handful of pioneering groups that understand that and are starting to make these model-based standards.
Sounds good, Tim. Thank you. We are almost at the end of our time. And there is one topic that I want to touch, and I believe, Dean, you can help me with that. That we have talked about how to acquire the data, how to analyze it, the benefits of it. One thing that I would like to cover is how do we do when business strategies change? Because it happens. Sometimes the business wants to do X and then something happens and they decide to do Y. How do we deal with data and those changes?
When you have changes that have to be made, and you have to keep everything flexible in general within manufacturing and within all of data collection, we have to keep things more flexible when we're from gathering data to how we process it to what the end results are. Because things are changing, technologies are changing very quickly nowadays. We used to have people where this was our process, this is what we're doing, and this is the type of manufacturing we're doing. Well, now we're adding in other processes, additive manufacturing and other technologies. And as those change, so will our data. Our data will have to be flexible. And even our sensors are changing. Now we have more wireless sensors. We have more abilities to gather data at the actual process. And I like Jared's comment about closing loops, because I've always kind of had that philosophy of you have your closed loop here at the machine level for things like safety, for things that are process based that are going to cause a crash or going to create bad parts. You have to have those things at a very localized level. Then as you start to branch outwards of what the value is, yes, there's still that data may have value upstream, but you also have to be able to be flexible enough to change that. And especially now with some of the more virtual environments, we're going to have to continue doing that. But we also have to keep an eye on the fact, as Tim mentioned, is how do we make sure that we can access that data, but also make it a user-friendly experience? Because right now that's been a challenge. I mean, if you just turn something loose and say, okay, here it is, now you go program it, the likelihood is fairly low that people are going to want to engage with your system.
Thank you, Dean. So unfortunately, the time is up. I know we could keep talking about this for another hour, but I mean, we have a limited time today. We have some questions coming from our audience. We want to answer at least some of them. So let's have a quick break with Matt, and then we'll go to the questions from our audience.
Thank you all so much for that great presentation. As Edgar mentioned, we are going to move into the question and answer session. If you have a question for us today, please go ahead and enter it in the Q&A box and hit submit. We will get to as many questions as we can today. If we do not have time for your question, don't worry, we will reach out to you following today's session. And now, Edgar, I will pass it back to you and the group to answer some of our attendees' questions.
Thank you, Matt. We have some questions from our audience already coming. So we're going to address a few of them because we don't have time to answer them all. And let's start with this one. Is there value in making the data visual, and how does an organization do this? So who would like to answer that? Yeah, go ahead.
I'll take that one. I've got opinions for days. So absolutely, there's value in that. As I said before, manufacturing or starting that, that beginning of the journey has always been taking the decision-making process out of the hands of a human being and putting it in the hands of the machine. You can't hope to try and inform an intelligent device on what it needs to do without any understanding. It's like saying, hey, I want you to tell me what the energy of that light bulb is, and I'm going to give you the square footage of my floor. Like, it's just not, there's no correlation. So that first blush needs to be done by, the greatest computer in the world, the human brain, right? So at this point in time, it's not a question of whether it can be, it's how it should be. Visualization requires a very critical mind on what you're trying to solve. You're not just trying to look at process trends all the time. You're picking a problem statement and going after the specific information and applying that onto a screen in a way that allows you to get to answers quickly. So absolutely, there is 100% value in visualizing that information, especially in the early stages of your analytics journey. Always just ask yourself why, you know.
Fantastic. Thank you, Jared. We have another question from the audience, and it says, how should an organization organize its data?
Edgar, let me jump on that. That has a bit of the standards and information modeling and the reasons for those. We look at this data, by the way, in talking to these types of organizations in two ways, and I'll start with the operations. And it's really, they need to organize this in nominal / benchmark. What's a normal day? What's a normal operation look like? And then the next bucket is anomaly, and just start there. If we took it one more layer deeper, I would say when I'm looking and talking to operations managers, they want to know that they've got data organized on the machine, within the machine, closed loop, collision avoidance, very, very timely data, critical data happening there. You take that up a notch, you look at that cell, what we're talking about is real-time coordination. So this might be organized around publish, subscribe. I have material, I have ability to take that material, right? And that's what that happens. As you get to the full factory, the organization level is really at the edge and cloud. That's where historical analysis, that's really where we see a lot of the machine learning and all taking place. So the information technology white collar world, if you will, has done this well with repositories, databases, and data governance about what data goes where and for whom. We're starting to see that starting to occur at the production area, and they seem to be following suit in that same kind of mentality.
Thank you, Tim. The next question we have says, what value does historical data have, and can an organization use that as a baseline to compare future measurements against? Who wants to answer that?
I can answer that question.
Awesome. Go ahead, Mohsen.
Generally, any data could be valuable. And specifically, if we are talking about historical data in a big data analytics, and the value of that is going to be a little challenge existed embedded, because in the past, the data that obtained, the old data, is based on a traditional data. Means that the way that they was captured, the measure was different than the characteristic of the big data. In the new area that we are dealing, Industry 4.0, we are dealing the type of information that we get. The big data has some specific characterization like the volume, velocity, variety, some of the V's, which are part of the characteristic as we discussed. But traditional data lack those. So finding an infrastructure instead of the old data can be very challenging. But in reality is that if we can find a useful structure by analyzing, it's going to be the best use for the machine learning. As we explained, machine learning is going to be a tool which can be applicable for big data analytics, or even to be used by artificial intelligence. Those algorithms or predictive behavior, the old data can be captured here, but is it going to be useful? Is those infrastructure or the structure that in the past or in the history they have been captured is going to be applicable? Is going to be the challenges of the model developer or the machine learning algorithm developer, how he or she can going to use those old data, create the model, and use it for future learning experience. This is challenging, but it's going to have a very good application for the machine learning in the big data analytics.
Thank you, Mohsen. The next question we have says, what factors need to be considered when deciding on a data analysis strategy?
Yeah, I'll take that one, Edgar. I mean, we don't exactly have a couple hours to answer this one, but I mean, I think if we're looking at sort of three big things to keep in mind with this, I think you need to look bottom up, top down, and change management. So bottom up, standards need to be in place, and not standards that fit today, standards that fit today and tomorrow. So as you gather more and more data, you know, how can you take in this additional data and still keep it within, you know, still store it and still categorize it in a manner that's going to make sense down the line. From the top down, having a strategy in place as to how we address different scenarios, what we as an organization want to look at, what's important, and to prioritize, how we approach this analysis. You're not going to be able to analyze everything off the bat. You're going to have to, sort of put in place what you want to do first, second, third, and fourth. And then finally, change management. I mean, when we look at Industry 4, one of the things that always gets talked about is people, process, technology. And when we start to do this analysis, we're going to have to take these analyses and apply them to something for there to be value to it. And change management is going to be a major part of this. Being able to have somebody in the organization that can take the people and the departments and everything and get them from the old model of being reactive to start to look at predictive, start to convince them as to why they need to collect data in a certain way, why they need to make sure that data is clean, why they need to be able to use or how they can use this data to really impact their operations and make sure that happens. So I think if we look at those three factors, that's a really good starting point. But again, super long conversation. We can go on for a while here.
Thank you very much, Ryan, for taking it. Now, the last question is very, I believe is kind of aligned to this. It's very useful for people making the decision makers in companies. And is, what is a realistic roadmap for manufacturers to adapt big data?
I'll take that, Edgar.
Thank you, David.
First of all, the problem that every company faces right away is intimidation. They are so scared by even taking their foot and putting it in the water. They don't know where to begin. So trying to keep it as simple as possible for what you're trying to do. And when you're looking at your system, say, I'm only going to take and bite off this small bit. How do you eat an elephant? One bite at a time. So just take that small step as you move forward to get your foot wet. And then as you start to become more comfortable, this is going to give you the confidence you're going to need to really say, look, here we've gathered good data. We can act upon it. It's something that is now something we can branch out through the rest of our machines, through the rest of our company. But you got to get in there and you can't be afraid. I know it's really intimidating for most companies to look at and say, gosh, I got all these machines. I have all this equipment. How do I do this? Well, you got to start with one small project. Start with that. Then that gets everybody else behind you. It gets your management team behind you. It gets all the executives and your C-suite people. All of them get buy-in because they've seen a benefit to it. So that's, to me, that's the biggest thing, overcoming the intimidation of starting.
Thank you very much, Dean. So that concludes our panel today. Thank you, all of you, the panelists here, for taking the time to share your knowledge and experience with us and the rest of the audience. Thank you, our audience, for being here, sharing your time with us too. And we hope to see you again in our next panel of this series. We're also grateful to Rockwell for all the efforts that is doing to make smart manufacturing a reality. And finally, for globalspec.com, thank you to the millions of technical professional engineers who have allowed us to connect them to the parts and services they need for project success. So Matt, back to you.
Thank you, Edgar. Now just a few items before we end things today. I would like to say a huge thank you to all the panelists today and to Edgar for leading our discussion. And a special thank you to Rockwell Automation for sponsoring this Defining the Smart Manufacturing Journey series. Today was session 1 of our 4-part series. Please join us for the rest of our sessions. You can visit our series page using the link listed in the resource widget. Sign up for all the sessions today. You won't want to miss it. And one last thank you to our audience members for being here with us today. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with your colleagues. Again, thank you for taking the time to attend this Global Spec Series event. Take care, and we'll talk with you soon.